A power transformer is usually employed for the purpose of converting power at a fixed frequency from one voltage to another. If it is used for converting power from a high voltage to a low voltage, it is called a step-down transformer. The conversion efficiency of a power transformer is extremely high and almost all of the input power is supplied as output power at the secondary winding. For confirming the specifications and performances of an electrical power transformer, it has to go through the open circuit test, no-load test on the transformer. In this video, we will learn about the open circuit test and its procedure. Objectives of the open circuit test. To conduct standard open circuit test in order to find the parameters of the equivalent circuit of a transformer. Evaluate the regulation and efficiency of the transformer at a given load. Check the excitation characteristics of the transformer. Open circuit test on transformer. The connection diagram for the open circuit test on the transformer is shown in the figure. A voltmeter, wattmeter, and our ammeter are connected to the low voltage side of the transformer as shown. The voltage at rated frequency is applied to that low voltage side with the help of a variac of variable ratio autotransformer. The high voltage side of the transformer is kept open. Now with the help of variac, the applied voltage gets slowly increased until the voltmeter gives a reading equal to the rated voltage of the low voltage side. After reaching the rated low voltage side voltage, all three instruments reading, voltmeter, ammeter, and wattmeter readings are recorded. The ammeter reading gives the no-load current LE. As no-load current LE is quite small compared to the rated current of the transformer, the voltage drops due to this current that can be taken as negligible. Since voltmeter reading V1 can be considered equal to the secondary induced voltage of the transformer, the input power during the test is indicated by wattmeter reading. As the transformer is open circuited, there is no output. Hence the input power here consists of core losses in the transformer and copper loss in the transformer during the no-load condition. But as said earlier, the no-load current in the transformer is quite small compared to the full load current. So, copper loss due to the small no-load current can be neglected. Hence, the wattmeter reading can be taken as equal to core losses in the transformer. Let us consider wattmeter reading is PO, where Rm is shunt branch resistance of transformer, if Zm is shunt branch impedance of the transformer. Therefore, if the shunt branch reactance of the transformer is Xm, these values are referred to as the low voltage side of the transformer because the test is conducted on the low voltage side of the transformer. These values could easily be referred to the high voltage side by multiplying these values with the square of transformation ratio. Therefore, it is seen that the open circuit test on the transformer is used to determine core losses in the transformer and parameters of the shunt branch of the equivalent circuit of the transformer. Dear sir, thanks for watching my videos. For more updates, please subscribe to our channel Learning Engineering and get a notification to press the bell icon.